In this video, I will work through free response question number 4 from the 2003 Form B AP exam. Number 4 is a no calculator question. A particle moves along the x-axis with a velocity at time t greater than or equal to 0, given by v of t equals -1 plus e to the 1 minus t power. For part A, find the acceleration of the particle at time t equals 3. So we know that acceleration is the derivative of velocity. So let's go ahead and find the acceleration formula by taking the derivative of velocity. So we will write acceleration at t is equal to v prime at t. And let's do it. The derivative of -1 is 0, so that's gone. The derivative of e to the something, technically we're doing the chain rule. So the derivative of e to the something is still going to be e to the something. So I'm going to write e to the 1 minus t power. But then we need to multiply by the derivative of the inner function here. The derivative of 1 minus t is -1. However, I'm going to go ahead and put the -1 in the front. So this is the acceleration equation. If we want the acceleration at time t equals 3, we will just evaluate a at 3. So this will equal -e to the 1 minus 3 power. You could leave it like that, but you would feel a little silly for not doing 1 minus 3. So I'm just going to go ahead and put e to the -2 power, and then I will stop. So that's the answer to part A. Part B is the speed of the particle increasing at time t equals 3. Give a reason for your answer. Let me hit you with some extra knowledge that you're going to need. If velocity and acceleration both have the same sign, then the speed is increasing. If the velocity and acceleration have opposite signs, then the speed is decreasing. I think of it this way. If velocity and acceleration have the same sign, that means they're working together. So that's why the speed would be increasing. If they have opposite signs, then velocity and acceleration are sort of working against each other, and that's why the speed would be decreasing. We already know that the acceleration at time t equals 3 is negative. E is a constant, a positive number, and having the -2 power just means 1 over e squared. And so this part is a positive number. Having the minus sign in front guarantees that the overall acceleration is a negative value. So the acceleration is negative. Let's find the velocity at time t equals 3 and see if it's also negative or if it's positive. We are given the velocity equation, so let's just evaluate at time t equals 3. V at 3 will equal -1 plus e to the 1 minus 3 power. So that's v at 3 is equal to -1 plus e to the -2 power, which would be the same thing as -1 plus 1 over e squared. So we are asking ourselves whether this value is positive or negative. E is a constant that is approximately 2.72, and we're squaring that. So we have 1 over some number that is definitely bigger than 1. So that means this overall fraction is going to be some decimal that is between 0 and 1. If we add -1 plus some decimal that's between 0 and 1, the overall result will be negative. It's going to be less than 0. So now we see that the velocity is negative and the acceleration is also negative. So therefore, since the velocity and acceleration have the same sign, the speed is increasing. Let's just write up that answer. So we can say the speed of the particle is increasing at time t equals 3 because the velocity and acceleration are both negative. Part C. Find all values of t at which the particle changes direction. Justify your answer. We know that the particle changes direction when the velocity changes signs. So our strategy will be to make a sign chart of velocity and see where it changes signs. In the setup, we were given this function for velocity. To make the sign chart, we need to know where velocity is equal to 0. So we need to know where negative 1 plus e to the 1 minus t power is equal to 0. Adding 1 to both sides, we have this. We can cancel out the base e by taking the natural log of both sides of the equation. Then we have just 1 minus t on the left-hand side. Hopefully you've memorized that the natural log of 1 is 0. Adding t to both sides, we have t is equal to 1. Now we can make the velocity sign chart by putting a value of t equals 1 on a number line across the top. We just need to decide whether the velocity function is positive or negative in each interval. For the first interval, we need to pick a value of t that is less than 1. Let's use 0. Substituting 0 in for t gives us negative 1 plus e. E is about 2.72, so negative 1 plus e is definitely positive. So velocity is positive in the first interval. In the second interval, we need to pick a value of t that is bigger than 1. How about 2? So v at 2 will equal negative 1 plus e to the 1 minus 2 is negative 1. This is definitely negative. We know this expression is negative because e to the negative 1 power is 1 over e. So that's about 1 over 2.72. That is a decimal between 0 and 1. If you take a decimal between 0 and 1 and then subtract 1, that's a negative number for sure. So the velocity is negative for values of t greater than 1. Since the velocity changes signs at t equals 1, we know that the particle changes direction at t equals 1. Let's write up the summary. The particle changes direction at t equals 1 because velocity changes signs. Part D. Find the total distance traveled by the particle over the time interval from 0 to 3. We know that distance traveled is the integral of the velocity function, but you have to be careful. If I wrote it this way, this would mean the net distance traveled, not the total distance traveled. So we need to do the absolute value of velocity. For example, imagine a particle at 0. It travels 3 units to the right. Because it is to the right, that is a positive 3 units. But then it travels 2 units to the left. Because it is to the left, that is negative 2 units. That is a net distance or displacement of positive 1 units. That's what we are calculating when we take the integral of velocity without the absolute value. We're finding the net distance. We're finding the displacement. But if we wanted the total distance traveled by the particle, we'd want to count all 5 units, 3 to the right, 2 to the left, total of 5. That's where the absolute value comes in, because if we can take the absolute value of the negative portion, then we will end up with a positive 3 and positive 2 for a total of 5. So hopefully now you're convinced why we need the absolute value. The key about absolute value is that we are making sure that velocity is always positive. Looking back at our work from Part C, we remember that velocity is positive to the left of t equals 1. So from 0 to 1, the absolute value is not really doing anything. It's already positive. So we can just leave velocity alone and use the original equation from 0 to 1. we need to integrate from 0 to 3. So far, we've got the integral from 0 to 1, and we can leave the velocity alone because it's already positive, the absolute value is not doing anything. But now we must continue and integrate from 1 to 3. We're integrating the rest of the way. So what's going on? Looking back at part C again, after t equals 1, velocity is negative. So that means in order for velocity to be positive, we will have to do the opposite of our velocity function from 1 to 3. So between 1 and 3, velocity is negative. But if I go like this, bam, now it's positive. At the beginning of the problem, we were given the velocity formula. V at t is -1 plus e to the 1 minus t power. So from 0 to 1, we can just substitute in the formula as is. So the integral from 0 to 1 of -1 plus e to the 1 minus t power dt. But from 1 to 3, we need to do the opposite of this function. So I'm just multiplying everything by -1. So I'm going to have +1 and minus e to the 1 minus t power dt. So now I'm integrating this term by term. The integral of -1 is going to be -t. I'm doing a u substitution in my head, so I'm getting negative e to the 1 minus t power. I will show you what I did off to the side. But let me go ahead and put the limits of integration from 0 to 1. Here's the mental u substitution that I just did, just in case you need to see it. Let u equal the 1 minus t, then u prime is going to equal -1. So this will be the integral of e to the u, and instead of dt, we will write du, but we will divide by u prime. So we're dividing by -1, which would be the same as multiplying by -1. The derivative of e to the u power is still e to the u power. We don't need the plus c because it is actually a definite integral. So that part doesn't change, and we just bring down the -1. And then u was the 1 minus t. So we have negative e to the 1 minus t power. So really, nothing changed except for we got a negative sign in the front. So that's what happened here. We took the integral of e to the 1 minus t power, and nothing really changed except for that's where the negative sign came from. So when it comes to this mental u substitution, if you look at the thing that you are wanting to make the u, if the derivative is just -1, you know it's just going to end up being a negative in the front. All right, it's coming up again over here. So integrating from 1 to 3, the integral of 1 is going to be t. And then again, when we take the integral of e to the 1 minus t power, the derivative in this area is -1. So that's just going to end up in the front, which will cause this negative to turn into a positive. So we will end up with positive e to the 1 minus t power. And this is from 1 to 3. So evaluating from 0 to 1, I do the value at 1 minus the value at 0. Similarly, to evaluate from 1 to 3, I do the value at 3 minus the value at 1. And guess what? Because this is a free response question, we can leave our answer just like this, as ugly as it is. And maybe you should leave your answer like this, because if you make a mistake as you simplify, you will lose points. So it's safer actually to stop here. I'm going to keep going just because it's more satisfying, but feel free to leave your answer like this. So we will have -1, e to the 0 power is 1. So we have negative 1 minus 1. And then this 0 is gone. And this will just be negative e to the 1 power, which is just negative e. So then over here, we have 3 plus e to the negative 2 power minus 1 plus e to the 0 power. So e to the 0 power is 1. So negative 1 minus 1 is negative 2. Minus negative e is positive e. 1 plus 1 is 2, so that's where this minus 2 came from. Now combining like terms, if we do negative 2 plus 3 minus 2, that's just going to be negative 1. So we have negative 1 plus e to the negative 2 power. And that's about as simplified as we could make it. So that's it.